All right, this is about to get fun. What is the solution to 3 to the power of x plus 1 equals 5 to the power of x? So what we're going to do is we're going to use logarithms to solve this exponential equation. So we just had a formula or a property in our last example that says, well, we've seen a couple things. Can we rewrite this with the same base, 3 and 5? No. So we can essentially take the log of both sides and then work with the logarithms. So we can rewrite this as log of 3 to the x plus 1 power equals log of 5 to the x power. All right, in a previous lesson, so now let's work with this. In a previous lesson, we did see how we had exponents with logs. When you have an exponent, you can drop your exponent out front. So that's an x plus 1 times the log of 3 equals, here's an exponent we can drop out front, x times the log of 5. Okay, well, we're getting somewhere here, right? So what we're going to do now is we are going to take this x plus 1 times the log of 3. Remember, log of 3 is now just, that's a number. That's log base 10 of 3. You could type in your calculator. We're going to keep writing it as log of 3 because it's a more exact answer. But we can take that log of 3, and it's almost like we're going to distribute it. Log of 3 times x is x log of 3. And then log of 3 times 1 is just plus 1 times log of 3. Now what we want to notice is that we're solving for x essentially, right? So we have an x here and we have an x here. So let's get our terms that have an x to the same side. So we can take that x times the log of 5 and subtract that from both sides. So let's subtract an x log of 5. At the same time, I want to get this log of 3 over to the other side by subtracting a log of 3. So I'm just kind of doing two steps at the same time. This is essentially just adding or subtracting terms to get them to the other side of the equal sign. So we have x log of 3 minus x log of 5 equals, when we subtracted that log of 3 to the other side, we had a negative log of 3. All right, so we have our x's on the same side. We've got these two terms that both are being multiplied by an x. So that x essentially is a common factor of both of these terms. So we're going to factor out the x, and it leaves us with log of 3 minus log of 5. And just to check, I could multiply that back in and end up with this statement above. So all we did was we factored out a GCF, factored an x out front. And what that allows us to do is solve for x, because now x is being multiplied by that log 3 minus log 5. So why don't we divide by log 3 minus log 5 on both sides. Log 3 minus log 5 divided by log 3 minus log 5 cancels. We got our x alone. So x equals a negative log 3 divided by log 3 minus log 5. That's something we can type into our calculator. So if we type that into our calculator, a negative log of 3 divided by, we would want parentheses around that denominator, and that would give us about, we'd have to do some rounding, a 2.15. So x is equal to 2.15. We did kind of a lot there to get that, didn't we? So does x really equal a 2.15? Well, let's go back to the original equation. If you have 3 raised to the, it says x plus 1, so I'm going to plug in a 2.15, add 1. That should equal a 5 raised to the 2.15 power. And if we simplify this and simplify this, just type it into our calculator, they're both equal to, and I'm doing some rounding here, but 31.8. So we can see that it does work out, that x is equal to 2.15.